Hi everyone, welcome to my YouTube channel. I am Madam Rosmaya. I will post a new video every week. If you don't want to miss any of my video, click the subscribe button. Hi everyone, I am Madam Rosmaya. Welcome to my YouTube channel. We are going to discuss on physics topic semester 1, illustration of thermodynamic process with PV graph. Okay, let's say an ideal gas changes from state X to Y, then to Z and back to X. So this is the P graph. So the changes start from X to Y, then to Z, then back to X. And the curve here, ZX is isotherm at temperature T. So the reading here is P1 and the reading here is P2. And here is V1 and another one V2. So we discuss X to Y first. So we use first law of thermodynamic where delta Q equals to delta U plus work. So delta Q is the heat, delta Q is the change of heat, and delta U is the change of internal energy, and W is the work done. So in this case, it's a vertical line, so therefore no changes in volume. So if no changes in volume, so the work is zero because the volume is constant. So therefore the equation here become delta Q equals to delta U. Okay, the temperature at X is Tx, temperature at Y is Ty. So Tx is larger than Ty. So therefore, the temperature decreases. So internal energy will decrease too. Okay, because the temperature decreases. And decreases means the change in internal energy less than zero. Because if you calculate Ty minus Tx, because Ty is less than Tx, so you get negative value. So we can write like this, delta U less than 0 to represent the decreasing temperature. Okay, then from the relationship here, if delta U decreases, delta Q also decreases. So delta Q is less than 0. Okay, this means heat is lost from the gas. Okay, next we discuss Y to Z. So we still use the first law of thermodynamic equation, delta Q equals to delta U plus work done. Okay, so the volume increases from V1 to V2 and the pressure is constant because this is horizontal line. So we can use W work equals to P delta V. So we can substitute into here, we get delta Q equals to delta U plus P delta V. Okay, this is the expansion process and the constant happen at the constant pressure. So the volume increasing, okay, V1 to V2. So delta V is larger than 0 because increasing. So if delta V larger than 0, so the work also larger than 0, okay, from this relationship. Now from the graph PV graph here, area under the graph of line YZ, okay, is the work done, work done by the gas because volume is increasing, so the work done by the gas. Okay, the area is given by this rectangle YZ V1 V2. Okay, the temperature is also larger than 0, or another word is increases, okay, because Tz is larger than Ty. Okay, Tz is temperature at Z, Ty is temperature at Y. So Tz larger than Ty. So the temperature increases. We write as delta T larger than 0. Okay, so because delta T larger than 0, the internal energy change in internal energy also larger than 0, because internal energy depends on temperature. Okay, now we substitute both work larger than 0 and delta U larger than 0. Another word is work increasing, change in internal energy also increasing. So therefore delta Q also increasing or larger than 0. Therefore delta Q bigger than 0. So this means heat absorbed by the gas. Okay, larger than 0 means heat absorbed by the gas. So from Y to Z, heat is absorbed by the gas. Okay, work is done by the gas, heat is absorbed by the gas. Okay, next we discuss Z to X. Okay, this is isotherm. So the changes from Z to X from the first law of thermodynamic, delta Q equals to delta U plus work done. So delta U is 0. Okay, temperature remain constant because this is the isotherm. Okay, the curve is isotherm. So the internal energy is 0 because temperature is constant. Okay, because this is the curve, so therefore the work is integration of V2 to V1 with respect to V. P with respect to V. So delta Q equals to work done. Okay, this is compression and isothermal compression and happen at constant temperature. Okay, so therefore the work done also less than 0, because this is the work done on the gas. And delta Q also less than 0 because the work less than 0 from this relationship. So if the work decreases, delta Q also decreases. Okay, then the work done on the gas is changed to the heat loss to the surrounding. Represent by the area under the graph here. Okay, now compare the two graphs just now. Okay, Y to Z is the heat absorbed, and then here is the heat loss, okay, from the gas. Okay, X to Y and Z to X is represent the heat is lost from the gas. Okay, the process here. So we find that the heat loss during X to Y and Z to X is bigger or larger than the heat absorbed during Y to Z. Okay, compare these two. So here is larger. The heat loss is larger. Heat loss is greater than the heat absorbed. So therefore the net work is done represent by the area here. Okay, work done on the gas, which is represented by the shaded area. Okay, so that's all for the example given here. The process change from X to Y, Y to Z, and Z to X. Okay, that's all for the discussion for today, and thank you for watching. Okay, and don't forget to like, subscribe, and comment.